Hello everyone, welcome to my channel Chemistry is Fun. Today we will study nomenclature of organic compounds. So nomenclature means we have to name the organic compounds. So in order to get a compound's scientific name and also to get a rough sense of its chemical structure, we follow certain rules which are specified by IUPAC. Now, what is IUPAC? IUPAC is International Union of Pure and Applied Chemistry. Now, they have laid out certain rules based on which we can do the naming of the organic compounds. If we follow these rules, first of all, wherever you go, these rules are followed, so we can say it is universal, as the name suggests, international. At the same time, this also will give us a rough sense of how the chemical structure of that particular compound will be. And it is very systematic, following the rules, and just by seeing the name, we can understand what type of functional group should be present. So we can have an idea about the class of that chemical compound. Now these rules, they are published in the Nomenclature of Organic Chemistry, and we call that as the Blue Book. Now if you see, the IUPAC name of any organic compound consists of three parts. First part is prefix, word root and the suffix. Now first let us see one by one. What do you mean by word root? Word root tells us or indicates the nature of basic carbon chain. For any organic compound, it is basically made up of carbon. So first of all, we should know the number of carbon atoms which are present in that compound. Now if the chain has only one carbon atom, like as in case of methane, 1 to 4 carbon atoms are present in that carbon chain, then we have special word roots for them. But 5 carbon atom onwards, they are known by the Greek numerals. So from the chain length, we have specific word roots, as we can see in this particular table. If there is only one carbon, the word root will be meth, as we find in methane, CH4. If there are 2 carbons, the word root will be ethane, eth. Word root is eth. Word root for 2 carbon is ETH, eth. Example is ethane, C2H6. You see this ethane molecule has 2 carbons. It is an alkane. So its chemical formula is C2H6. If there are 3 carbons, the word root will be prop. For 4 carbons, the word root is but, like in case of butane. Butane means, it from the word only we can understand there must be 4 carbons present. 5 carbon onwards, you see 5 carbon is pentane, then hexane, 6 carbon hexane, like that. For 10 carbon it is DEC, dec. 6 carbon will be hex, C6 hex. The word root will be hex, HEX. C7 hept. C7 will be hept, HEPT. C8 8 carbons, oct. C9 9 carbons, NON. For 10 carbons it is dec, DEC. 11 undec, to C12 dodec, C13 tridec, and so on. C20 20 carbon, we will call it ICOS. C20 ICOS. For 30 C30 triacont, C30. C30 triacont, TRIACONT. So these are the word roots. So in general, the word root for any carbon chain is ALK, alk. Word root for any carbon chain in general. In general, the word root will be given as ALK. Like in case of alkane, ALK, alkene, again ALK, alkyne, again ALK. Then we come to suffix. They are of two types, primary and secondary. We will see one by one. The primary suffix can be N, ANE, or ENE, or YNE. If it is a single bonded carbon atoms, means all the bonds are single bond, the primary suffix will be N, ANE. Like in case of alkane, this is the general formula for alkane, CnH2n plus 2. In case of alkene, if there is a double bond, general formula for alkene, CnH2n. As in case of pentene, ENE, you see, in case of ENE, double bond, if there is a double bond present between any two carbon atoms, as in case of pentene, general formula is CnH2n. For pentene, specific formula for pentene is C5H10. We have seen word root, pent. Word root in pentene is pent, means 5 carbon atoms should be there. So it is C5H10. General formula for alkenes is CnH2n. So here also you see carbon atoms 5, hydrogen atoms 10. 5 2s are 10. So it is following the general formula rule for alkenes, C5H10, pentene. Next is third one, wine. If there are 3 double bonds between 2 carbon atoms, the YNE, wine, primary suffix wine will be used. As in case of pentyne, the name suggests that pent word root means there will be 5 carbon atoms. Since it is wine, YNE, wine means 1 triple bond should be there. General formula, this is the general formula for alkyne, CnH2n minus 2. CnH2n minus 2. So how we can calculate? You see C5H8. C5, put N as 5. So C5, how many hydrogen should be there? Multiply 5 by 2, subtract 2, 2n minus 2. So 5 2s are 10, minus 2 is 8. So it is C5H8, pentyne. Now in case the parent carbon chain has 2 or 3, 4 or more double or triple bonds, then we can add numerical prefix. If there are 2 double bonds, di, 3 double bonds, tri, 4 double bonds, tetra, that should be added to the primary suffix. Now same will be the case for triple bonds also. For example, if there are 2 double bonds, we will call it diene. As in case of 1,3-butadiene. You see the structure, 1,3-butadiene. In this there are 2 double bonds. This is one double bond, another double bond. There are 2 double bonds. So double bond means ene, ene should be the primary suffix. Here there are 2 double bonds in the same molecule. So the primary suffix becomes diene. 1,3-butadiene. Why it is buta? Because there are 4 carbon atoms. 4 carbon. 1, 2, 3, 4. 4 carbon atoms means word root should be but. 1 and 3 suggest the position of the double bonds. You see, if we see, this is carbon number 1. This is number 2. This is third carbon. This is fourth carbon. One carbon, first carbon is having a double bond. Third carbon is also having a double bond. So it is 1,3-butadiene. Now we come to secondary suffix. Secondary suffix is added after the primary suffix so that it can indicate the particular functional group. As we have heard about the compounds like alcohol, aldehydes, ketones. So they have a particular functional group. So we have a list of secondary suffix for the functional groups. For example, we will just have a look at the class of the compounds, their functional groups and the secondary suffix associated with it. If it is an alcohol, functional group is OH, suffix will be OL. Dash OH suggests that the oxygen will be attached to the, this is a single bond. It is attached to some carbon. So alcohol is OH, suffix is OL. Suffix will be OL. As in case of ethanol. One example, ethanol. It's an alcohol. So you see, we get the suffix OL. Next is the group of aldehydes. Aldehydes. In case of aldehydes, functional group is CHO. Suffix used will be AL. Suffix like in case of propanol. In case of ketones, the functional group is C double bond O. The suffix is ONE, on, as in case of like propanone. Carboxylic acids have a functional group COOH and secondary suffix will be oic acid. Oic acid like propanoic acid. Propanoic acid. Next we have acid chloride. COCl. COCl is the functional group and the suffix will be oil chloride. For acid amides, functional group is CONH2. Functional group CONH2, acid amide, functional group CONH2, secondary suffix amide. Esters, COOR. COR is the functional group for esters. COR is the functional group, and how we will be having the secondary suffix alkyl OAT like alkanoate. We will see in detail afterwards along with examples. Nitriles. Nitriles functional group is CN and secondary suffix will be nitrile. In case of thiols, thiols have a sulfur. Like alcohols have OH, thiols will have a sulfur atom, SH, dash SH is the functional group. So thiols, dash SH and dash thiol. Similarly, amines, dash NH2 and amine. So amine is the secondary suffix associated with it. Now with an example, we can see the significance of word root, primary suffix and secondary suffix. We see this formula CH3CH2OH. We can see there are two carbon atoms, so the word root will be ETH, okay, and all are single bonds here, so primary suffix will be AN, ANE. Since there is a functional group as OH, so the secondary suffix will be OL, alcohol, OL. So the IUPAC name will be ethanol, ethanol. I hope you all could understand the topic.